Hello. In this section, I will focus on computing a limit with indeterminate forms, or actually, to be more precise, with indeterminate form, because we will focus only on one form out of 7. We have 7 forms, and I will not discuss them because we will discuss them later. We will focus on 0 over 0. Of course, we know it's related to the recent topics. Okay, we learn direct distribution property, and it says that if the function is continuous function and A is in the domain, the continuous at A, and its A, of course, is in the domain of the function, then the limit as x approaches A of the function f of x is basically the value f of A. We can directly substitute instead of x the quantity A, right? But we do have to have continuity at the point A. And of course, A is in the domain. Okay, let's see if we can always use this. Example number 1. Evaluate a limit as x goes to 1 of the function x squared minus 1 over x minus 1. We can see right away that x equals to 1 is not in the domain. This is still not a problem, since we're not calculating the value. I can say that value at 1, since 1 is not in the domain, does not exist. But we can still investigate how function behaves near 1. Let's do the direct substitution property. 1 squared is 1, 1 minus 1 is 0, and 1 minus 1 is 0. Of course, we do have a little bit of problem. We have 0 over 0. We remember this indicates that both of the polynomials from the numerator and denominator, they have something in common at 1, as x is approaching 1. That common factor has to be found out. We have to find out this common factor and cancel out. Of course, if this is possible, hopefully it is. And by doing some algebraic steps, algebraic manipulation, we can find out this common factor. Let's see. Oh, we will do it in a minute. This is just the procedure. If by direct substitution, we will get 0 over 0, we can find out this common factor, I'm just repeating, and we can cancel out. Then no longer we will have 0, quantity 0 in the denominator, and then we can directly substitute. Okay, we're getting back to this function. And x minus 1, the quantity in the denominator, is just linear term. It's the simplest form. But x squared minus 1, we can factor out x minus 1, x plus 1. And then we can see this common 0, common factor. We can cancel out, then the function becomes just x plus 1. And now we can directly substitute 1 plus 1 is 2. And what we did, we eliminate, we simplify a function to the function 1, x plus 1. Function x plus 1 is linear function with the slope, this is that function, x plus 1. Slope 1 and y-intercept 1. It's like this. However, this function at 1 is not defined. I'm supposed to have an open circle. And of course, is at the height 2. That's the limit. And this is the graph of this function. In order to play with this algebra, finding the common factor, we will need these formulas. I mean, you can pause the video and you can copy this, or you can treat this slide in this presentation as a reference page. Yeah, as we know, we just use this one. Okay. Okay, that means all of them will be extremely helpful. Okay, evaluate limit as x goes to 3, x minus 3 over x squared minus 9. Substituting instead of x3, we will get 0, 9 minus 9, 0. Again, 0 over 0. And of course, because 3 is not in the domain. But that's not a problem for the limit. Let's find out this common factor. We will factor out denominator, in this case, x squared minus 9 is x minus 3, x plus 3. And that's the common factor. That is the common 0. We did simplify function to 1 over x plus 3. Now we can use direct substitution property, and we can substitute instead of x, 3. 3 plus 3, 6, 1 over 6. And again, if we like, we may draw this function. However, I should be more careful because I just refer to the given limit, but also the value negative 3 is not in the domain, because 3 and negative 3, if we substitute to the denominator, will give us 0. And we are not allowed to divide by 0. Okay, that's mean negative 3. I can draw this because I would like to draw that simple form, 1 over x plus 3. Okay, and we can see this one, we can't simplify. This is partial fraction. This is the simplest fraction. And negative 3 instead of x will give us 0, and we will be never able to simplify this because we do not have a common factor. Then negative 3 will stay. But we also know, based on the transformation of the function, 1 over x plus 3 is the hyperbola in the first and the third quadrant, shifted 3 units to the left. Okay, that means I can draw, but I have to be careful, and I can draw this first and the third quadrant, but it's a little bit shifted. This value, when I put instead of x 0, is 1/3. Yeah, this is just the y-intercept. And of course, this is 3. Function is still not defined for 3. And that limit, it's 1/6. Okay, that means just to have this geometrical understanding. But in order to calculation, we did calculate the limit. The limit is 1/6. Okay, evaluate the limit at 1, x cubed minus 1 over x squared minus 1. Okay, again, 1 is not in the domain, and I can add the other value. Negative 1 is also not in the domain, but we will focus on 1. Substituting 1, we getting 0 over 0, of course. Oh, I didn't type, I will write the solution. Let's find out the common factor. Limit as x approaching 1. This one is x minus 1, x plus 1. X cubed minus 1 cube is a cube minus b cube. That's the formula from that reference page. We will do a minus b, and then a squared plus ab plus b squared. Okay, a is x, b is 1. X minus 1, and then x squared plus x times 1 plus 1 squared. And again, we can nicely see the common factor, x minus 1, that's the common 0, because that's 1 minus 1, 0. And now we can substitute 1. 1 squared, 1, 1, 1 plus 1, 3 over 2. Okay. And we will not draw, but the same thing, function at 1 will have that limit. At negative 1, we can see we can't factor out further this rational function. Negative 1 will stay like we will not cancel out, and probably will be the vertical asymptote. Example number 4. Okay. X plus 2 over x cubed plus 8. Find the limit as x goes to negative 2. Negative 2 plus 2 is 0. Negative 2 cubed is negative 8 plus 8 is 0. Okay, 0 over 0. And of course, I didn't mention, but if you will have 5 options on the multiple choice question, Please be extremely careful. This answer is most likely not 0, unless we cancel out that common factor 0 and we eliminated 0 from the denominator. And if still we have another 0 in the numerator, then yes, the limit is 0. Okay, let's find out this common 0. X -2 is not in the domain. Okay, limit as x goes to -2, x plus 2. Now what I will do, x cubed plus 2 cubed, similar formula, which is a cubed plus b cubed, x plus 2, and then x squared minus, now it's minus, 2 times x, and plus 2 squared, 4. Okay, x plus 2 times x squared minus 2x plus 4. Okay, we can see the common factor, common 0 is gone. Now we can substitute. 1, -2 squared, -2 times -2 plus 4. 4 plus 4 plus 4, 112. This is the limit at -2. Function will approach 112 from both sides. Example number 5. Square root of x minus 5 over x minus 25. We have to check how this function behaves near 25. Of course, 25 is not in the domain because substituting, we're getting 0 over 0. Let's find out common 0. The same main concept. We have to find out this common 0, common factor. In this case, we see the square root expression. If we will see the square root of expression, one of the easiest way is to multiply and divide by the conjugate expression. Okay? Conjugate is a minus b and a plus b. That's the conjugate expression. And if we will distribute everything, we will have a squared, b squared, and minus. And we will always look at this root expression, square root of x minus 5, and the conjugate expression is square root of x plus 5. And when we will multiply, we will square root, we will square 5, and of course minus. Okay, let's see. We will multiply and divide because we're not changing the original expression. Multiplying and dividing by the same quantity, we're not changing anything. Okay, now let's distribute like I did on the top of this slide, the numerator, but let's keep the product form in the denominator. Because when I will distribute denominator, I will lose that x minus 25. It will be like spread out. And we need this x minus 25 since this is our 0, our common factor. And now we can see common factor, common 0, gone. We can substitute 25. Square root of 25 is 5. 5 plus 5 is 10, 1 over 10. The limit exists. As x approaches 25, we will have empty dot at the level, at the height, 1/10. We will not draw the function, but at 25, we will have 1/10. I don't know exactly how the function looks like, but definitely at 25 behaves like this. Okay. Evaluate limit at 0, x plus 3 squared minus 9 over x. Of course, 0 in the denominator and 0 plus 3. 3 squared, 9, 9 minus 9, 0. Okay, the same thing. Let's find out this common factor. And actually, in this case, the common factor is just x. We have to figure out how to cancel out the x from the denominator. Let's start. Limit as x goes to 0. And you can probably see we can basically expand x plus 3 squared. X plus 3 squared is x squared plus 6x plus 9, and then minus 9. One thing that we can do, 9 minus 9, 0, and x squared plus 6x, we see the common factor. We can factor out x, and that's what we need. Common factor is gone. 0 plus 6 is 6. Okay, limit at 0 is 6. Of course, function is not defined at 0. We're not looking at the value. Value does not exist. I can add 0. The limit basically will be 6. Actually, we managed to simplify a function to the straight line, x plus 6, which is straight line with, but it's not defined at 0. That's at 0 is, right? That's actually the function, just a linear function with the x intercept -6, but y-intercept does not exist because y-intercept indicates that x has to be 0, but 0 is not in the domain. Example number 7. Again, function is not defined at 0, and when we substitute 0 to this expression, to this function, we have 0 over 0. Let's try to find out this common 0, common x. Okay, x, we will factor out x plus 2 cube. Okay, I can write a plus b cube. This is just a binomial. We can easily expand, or you can check the formula on that reference slide. Okay, we have a, b, a, b, a, b, a, b. And we are starting with power 3, 0, 2. Let's maybe do the powers of a first, the first quantity. 3, 2, 1, 0. Now b, 0, 1, 2, 3. Okay, and since this is addition, b is positive everywhere, we will have addition. And the only thing that we have to also remember, coefficients. And coefficient we can take from the Pascal triangle, 1, 3, 3, 1. Okay, let's see. Of course, b to the power of 0 is 1, a to the power of 0 is 1. Okay, a cube. In our case, a is x and b is 2. Okay, x cube plus 3 times x squared times 2 plus 3 times x times 2 squared, which is 4, and plus b cube, which is 2 cube. Okay, minus 8. Of course, 2 cube is 8. 8 minus 8 is 0. Let's see if we can. We have x cubed, x squared, and x. We can factor out x. That's what we need. It will be x squared. 6 we will get by multiplying 3 times 2. And 3 times 4 is 12. Okay. Let's factor out, let's cancel out. That's what we need. And now we can substitute 0. 0 squared plus 6 times 0 plus 12. Limit at 0 is 12. Okay. Function doesn't have a value at 0, but on the left and the right hand side, function will approach the height 12. Example number 8. Evaluate the situation at 0 for the function 1 over 2 minus x minus half all over x. You may notice substituting 0 instead of x, we're getting 0 over 0. Typical situation. Function is not defined at 0, but that's okay. We will find out this common 0. In this case, what we can simplify by finding the common denominator on the top. The common denominator is 2 times 2 minus x. 2 times 2 minus x. And I will multiply each term. I will multiply this, I will multiply this, and I will multiply the denominator. Okay. Okay, multiplying the first fraction, this will be gone because we can simplify. Only 2 will stay, minus. I can erase this because I will need this. When we will multiply 2 times 2 minus x times half, 2 will be gone. Then 2 minus x will stay, and please remember about the parentheses. Of course, in the denominator, I will not distribute because I need that x. I need this to be a factor, not the part of the expanded form. 2, and we will distribute negative, important, plus x. Important moment, sometimes we forgot, times 2. And we can simplify this, and now we can see the common factor. X and then x. We can nicely simplify, and we will be able to substitute 0, 1, 2 minus 0 is 2, 2 times 2 is 4. The limit is 1/4. And we can see how we can nicely algebraically play with these expressions. Example number 9. Evaluate the function tangent of x over secant of x at pi over 2. Okay, now we have a little bit different situation. Okay, let me check actually. Okay, because that's the other. That's actually the other indeterminate form. It's not 0 over 0. Okay? Because I did say that we will mainly focus on 0 over 0. But yeah, let's try to see what we can do. Because when we substitute, we know, of course, that tangent and secant is not defined at pi over 2. Okay. Because tangent at pi, tangent is basically sine over cosine, sine of x over cosine of x, and sine of x at pi over 2 is 1, that's okay, but cosine at pi over 2 is 0. We are not dividing by 0. And if we will know the graph of the tangent of x, at pi over 2, function has a vertical asymptote. Okay. That means function is definitely not defined. This function is not defined at pi over 2, but this is not a problem to evaluating the limit. Okay. Tangent and secant. Okay. The thing is, we have to be now extremely careful because we don't know on which side of pi over 2 we are. First of all, let's maybe compute at pi over 2 from the right-hand side, because just thinking about tangent. Okay, tangent looks like this. This is pi over 2, and of course, it's periodic function. It's another. Oh, okay. This will be negative pi. And we can see this is right-hand side, this is left-hand side. On the right-hand side, function goes, oh, no. Of course not, left-hand side and the right-hand side. On the left-hand side, function goes up. On the right-hand side, function goes down. That's negative infinity, positive infinity is involved. Okay, I choose the right-hand side. Limit of tangent on the right-hand side at pi over 2. Okay, let's see. It's actually, we can see function goes to the negative infinity. Yeah, function goes to the negative infinity. And now secant, how secant behaves at pi over 2. If we don't know the graph of secant, we can think as a secant of x as a 1 over cosine. okay? And cosine is definitely 0, right? Cosine at pi over 2, let's say from the right-hand side, it is 0. And we remember 1 over small number, 1 over 0 is a big number. But we have to figure out cosine looks like that. This is pi over 2. From the right-hand side, function is approaching that 0, that x-axis, from negative numbers. It means they are small numbers, negative. Then we will have, respecting arithmetic, positive 1 over negative values, negative tiny values, is negative. Positive over negative is negative. That means also negative. And we can ignore negative over negative, but we end up having second indeterminate form. Okay, let's, because this is also in this section, let's try to figure out. First of all, we will try to simplify, because this is also important. Indeterminate form, we cannot assume that this is infinity or maybe this is 1 when we, no, because infinity is not a number. We are not allowed to like use infinity in the arithmetic. We have to definitely rewrite. Let's try to rewrite this expression. Limit as x goes to pi over 2 from the right-hand side. With respect to the trigonometric function, we can definitely rewrite in terms of sine and cosine. That's always give us some options. Sine of x over cosine of x and 1 over cosine. Okay, and we will cancel out cosine, right? We can see this, but I can rewrite this sine of x over cosine of x, and dividing by fraction means multiplying by the reciprocal. Okay, and then we just end up with function sine over x. That means we manage algebraically to simplify, and sine at pi over 2 is basically 1. So we can see with this uncertain, of course, this is indeterminate form, but we don't know. And this is like, at the moment is indeterminate. Indeterminate doesn't really mean it's undefined. We have to figure out what to do. It could be undefined. Yes, we did get finite number 1. Of course, how did I get that 1? Sine at pi over 2. And from the left or the right-hand side, it will be 1. Okay. And from the left-hand side in general, that limit also will be 1, because we will cancel out, we will do the same procedure. Okay, and I think I have one more, another indeterminate form. Okay, let's see, evaluate the function f of x equals to 1 over x minus 1 minus 2 all over x squared minus 1 at 1. Both of these terms in this expanded form, they are not defined at 1, because 1 will give us 0. Right? We can definitely see as, that means they are not defined at 1, but we can still compute a limit as x is approaching 1. Because this will be 1 minus 1, it will be 0. Okay, it will be 1 minus 1, and then 1 minus 1. Let's say from the right-hand side. Actually, 1 is not in the domain. However, let's focus on x is approaching 1 from the right-hand side, because then we will have a little bit more than 1. This is 0, this is 0, but since this is a little bit more than 1, this will be positive, like tiny numbers, but positive, tiny numbers, positive. And then 1 over small number is a big number, 1 over small number is a big number. We end up having another indeterminate form, infinity minus infinity. Also, yeah, because this is in this section, let's focus. But as I mentioned at the beginning, 0 over 0 is the most important indeterminate form in this section, because in chapter 4, we will focus more on the other ones. But okay, let's do it. Infinity minus the same. We don't know. It could be anything. It's indeterminate form. We don't know. Let's try to figure out. Limit as x goes to 1, and let's say from the right-hand side. And this is a function. Let's see. Oh, no, it's not addition. Addition will give us no problem because actually infinity plus infinity is just infinity. Yeah, big number plus another big number. It's a big number. Okay, minus and x squared minus 1. Okay, we will probably, in this case, one of the way is simply to get common denominator and see if we can simplify some terms. Maybe we can eliminate these infinities. Common denominator, it will be, because this one we can factor out, x minus 1, x plus 1. Then the first fraction we can simply multiply by x plus 1. X plus 1. Right? Then we have the common denominator. Now the common denominator is a product of x minus 1, x plus 1, and we will have x plus 1 minus 2. It looks like we have x minus 1, x minus 1, x plus 1. We see the common factor because that's the 0, because 0, we can see here, 0 in the denominator was a problem. It wasn't 0 over 0, but still 0 in the denominator is a problem, which we can deal with. Common factor is gone. Now we can do direct substitution. X is approaching 1, 1 plus 1. The limit is 1/2. Yeah, it's amazing. Big number minus big number, and we getting 1/2. Finite number. That's the reason that this is indeterminate form, and we always have to double check and make sure that we have the right, correct answer. Okay, now I think we practice almost everything. You can check later the video about couple of limits with absolute value and couple of infinite limits. Okay, thank you very much. Enjoy all of the problems.